From that, the topic is fluid properties and flow characteristics. So these are the things we are going to see in fluid properties and characteristics. At first, these are the 8 things which are majorly contribute in fluid properties. The first thing is density, specific gravity, viscosity, surface tension, capillarity, compressibility, bulk modulus, and vapor pressure. We will briefly see each thing one by one. The first thing is density. So generally the density is defined as a fluid by its mass per unit volume at a standard temperature and pressure. So the formula for density is mass of the fluid by volume of the fluid. So density is equal to mass by volume. The unit of the density will be kg per meter cube. So the density for a normal water, the value will be 1000 kg per meter cube. The next thing is specific weight or weight density. So it is also defined as weight per unit volume at standard temperature and pressure. So the weight of the fluid is divided by the volume of the fluid, which gives the value of the specific weight. The formula here will be described in below, where W is equal to rho into G, the unit will be Newton per meter cube. So the weight density of the water will be 9.81 kilonewton per meter cube. And after that, the specific volume will become. The definition of the specific volume is unit mass of the liquid for a unit volume. That is small v, which defines a specific volume, and capital V, which defines the volume of the unit mass. So it gives small v is equal to capital V by M, that is 1 by rho. The unit will be meter cube per kg. Here 1 meter cube is 1000 liters. Second is specific gravity. It is the ratio of the specific weight of the liquid to the specific weight of the standard fluid. Here the specific gravity gives the specific weight of the liquid divided by specific weight of the pure water. Here we can see that weight density of the liquid, which gives S into weight density of water, that is S, which defines the specific gravity, and weight density of the water, we already seen that 1000 into 9.81 Newton per meter cube. By using these formulas, we will solve problem. The problem number 1 here, calculate the density, specific weight and a weight of 1 liter of the petrol of a specific gravity 0.7. So we have to find, here is density, specific weight and weight of 1 liter of petrol. The only given data is specific gravity. So from this, the given data will be V is equal to 1 liter, that is for 1 liter single liter. So 1 into 1000 centimeter cube, we are converting into meter cube. So 1 meter is equal to conversion. Here is 1 into 1000 centimeter cube. Here 1000 divided by 10 power 6 meter cube, that is 0.001 meter cube. Here the conversion will be given, and the specific gravity value is 0.7. Applying the 3 formula, we will get the value. First thing is density, that is rho. The formula will be S into 1000 kg per meter cube. Sorry. Here S value will be 0.7 and is 1000, that is 700 kg per meter cube. And second is specific weight. Here W is equal to rho into G, which is 700 into 9.81 Newton per meter cube. Multiplying these value, we will get 6867 Newton per meter cube. After that, weight, which will give weight divided by volume. So W is equal to small w by 0.00, which will be give the value of 6867 is equal to W by 0.001. Now we will find out the value by solving this. The W will be 6.867 Newton. So this is a simple sum which is applied by the basic formulas of the properties of the fluid. And the remaining properties we will see one by one. First thing is viscosity. Here we will see the types of viscosity. The first is dynamic viscosity and this kinematic viscosity. The dynamic viscosity is defined as the property of the fluid which offers resistance to the flow. That is tau is equal to mu du by dv. By solving the viscosity, we will put the unit as poise. Here, 1 poise will be equal to 1 by 10 Newton second per meter square. And as kinematic viscosity, it is defined as the ratio between the dynamic viscosity and mass density of the fluid. Here the one stroke is equal to 10 power minus 4 meter squared per second. And based on these properties, we will solve a problem. Here a plate is 0.025 mm distance from a fixed plate, moves at 60 centimeter per second and requires a force of 2 Newton per unit area, that is 2 Newton per meter squared. To maintain this speed, determine the fluid viscosity between the plates. So from the diagram itself, we have understand that dy value will be 0.25 mm and u will be 60 centimeter per second, and it is a fixed plate. The water will be moving inside it. So the given data are given based on the problems. So dy is equal to 0.025 mm, which will be given in the problem. So convert them into meter, that is 10 power 1 meter is equal to 10 power 3 mm. So 1 mm is equal to 10 power minus 3 meter. So u is equal to 60 centimeter per second. Also convert them into meter. Du is equal to u minus 0, that is initially you have a 0, final velocity of the value will be 0. So 0.6 meter per second, and tau is equal to 2 Newton per meter square. So the formula will be mu is equal to tau divided by du by dy. Tau value will be 2, du by dy, du value will be 0.6, dy value will be 0.00025. By solving this, we will get the mu value as 0.33 into 10 power minus 5 Newton second per meter square. So convert them into poise. We will get 8.33 into 10 power minus 4 poise. These are the types of fluids which are based on shear rate and shear stress. For our x-axis it will be an ideal fluid, for our y-axis it will be an ideal solid. By understanding the curves, we will see that from 0 to some peak value of 1, it will be a Newtonian fluid, and above the value of mu, it will be non-Newtonian fluid, and less than the value of 1, it will be non-Newtonian fluids. And above, when the shear stresses will be increased from 0 to some certain value, it will be have an ideal plastic stage and a plastic fluid stage. We will see that one by one. A fluid which is incompressible and is having no viscosity is known as an ideal fluid. It is only an imaginary fluid. In case of a real fluid, a fluid which is having viscosity is known as a real fluid. All fluids are real fluids. Newtonian fluids. These fluids follow Newtonian viscosity equation. For each such fluids, mu does not change with the rate of deformation. The example will be water and kerosene. Non-Newtonian fluids, that fluids which do not follow the linear relationship between the shear stress and the rate of deformation. The example of non-Newtonian fluids will be polymer solutions and blood. And finally, the surface tension of the liquids. The phenomena of surface tension arises due to two kinds of intermolecular forces. Surface tension is caused by the force of cohesion at the free surface. Now we are going to see about the difference between cohesion and adhesion. The force of attraction between the molecules of the same liquid is called as cohesion. Surface tension is due to cohesion between particles at the free surface. The force of attraction between unlike molecules of a solid boundary surface in contact with the liquid is called as an adhesion. And the last thing is capillarity. Capillarity is a phenomenon by which a liquid rises into a thin gas tube above or below its central level. Surface relative to the adjacent level of the liquid is called capillarity. The phenomena is due to the combined effect of cohesion and adhesion of a liquid particles. From the diagram itself, we can see the difference between a capillarity rise and capillarity depression. For a water, the theta value will be 0. For mercury, the theta value will be 140 degree. So this is a wetting fluid and non-wetting fluid based on water and mercury. And finally, the bulk modulus and compressibility. It is defined as the ratio of the compressive stress to the volumetric strain. The negative sign indicates the volume decreases as the pressure increases. Compressibility, when a fluid is subjected to a pressure increases, the volume of the fluid decreases. It is known as compressibility. It is reciprocal of bulk modulus. Thank you.